This lecture is on Hess's law. Hess's law is a scheme designed to find the enthalpy of a reaction by adding a series of reactions where intermediates may be present in one or more steps. Some possible scenarios may involve 1. Flipping a reaction, and or 2. Multiplying one or more reactions by a factor. If you multiply a factor to a chemical equation, so too must delta H reaction by that same factor. A plus 3C forms D delta H1. If 1 multiplies by 2, then 2A plus 6C forms 2D delta H2 equals 2 times delta H1. If you reverse a chemical equation, the sign of the delta H reaction must be reversed also. A plus 3C forms D delta H1. If reversed, D forms A plus 3C delta H2 equals negative delta H1. Sample problem 1 is, find the delta H for the reaction below given the following reactions and subsequent delta H reactions. PCl5 forms PCl3 plus CO2, delta H overall equals blank. P4 plus 6Cl2 forms 4 PCl3, delta H1 equals negative 2439 kJ. 4 PCl5 form P4 plus 10 Cl2, delta H2 equals 3438 kJ. Step 1. Add the reactions together, cancel identical substances. After doing this, delta H equals 999 kJ. Step 2. Divide the reaction and enthalpy by 4. After doing this, delta H equals 249.8 kJ. Sample problem 2 is, find the delta H for the reaction below given the following reactions and subsequent delta H reactions. 2C2H4O plus 2H2O forms 2C2H6O plus O2. Delta H overall equals blank. C2H6O plus 3O2 forms 2CO2 plus 3H2O. Delta H1 equals negative 685.5 kJ. C2H4O plus 5 halves O2 forms 2CO2 plus 3H2O. Delta H2 equals negative 583.5 kJ. Step 1. Flip reaction 1. Delta H1 sign will change. If we flip reaction 1, which had a delta H equaling negative 685.5 kJ, after reversing the reaction, the delta H for reaction 1 is now positive 685.5 kJ. Step 2. Multiply both reactions by 2. If one performs this, reaction 1 will be 1371 kJ, and reaction 2 will be negative 1167 kJ. Step 3. Add the reactions together, cancel identical substances. After canceling all like substances, delta H overall is 204 kJ. Sample problem 3 is, find the delta H for the reaction below given the following reactions and subsequent delta H reactions. N2H4 plus H2 forms 2NH3. Delta H overall equals blank. N2H4 plus CH4O forms CH2O plus N2 plus 3H2. Delta H1 equals negative 37 kJ. N2 plus 3H2 forms 2NH3. Delta H2 equals negative 46 kJ. CH4O forms CH2O plus H2. Delta H3 equals negative 65 kJ. Step 1, flip reaction 3. If we flip reaction 3, delta H3 is 65 kJ. Step 2, add the reaction together, cancel identical substances. If one does that, delta H overall is negative 18 kJ. Here are a couple of review exercises for you to try. Review exercise 1 is find the delta H for the reaction below given the following reactions and subsequent delta H reactions. CO2 forms C plus O2, delta H overall equals blank. H2O forms H2 plus half O2, delta H1 equals 643 kJ. C2H6 forms 2C plus 3H2, delta H2 equals 190.6 kJ. 2CO2 plus 3H2O forms C2H6 plus 7 halves O2, delta H3 equals 3511.1 kJ. Review exercise 2 is find the delta H for the reaction below given the following reactions and subsequent delta H reactions. Half H2 plus half CO2 forms HCl. Delta H overall equals blank. COCl2 plus H2O forms CH2Cl2 plus O2. Delta H1 equals 47.5 kJ. 2HCl plus half O2 forms H2O plus CO2. Delta H2 equals 105 kJ. CH2Cl2 plus H2 plus 3 halves O2 forms COCl2 plus 2H2O. Delta H3 equals negative 402.5 kJ. For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.